Hello, fellow Java developers. Welcome back to our starter course on Apache Camel. In this video, we will take a look at how errors can be handled in Apache Camel. We will learn to use error handlers, onException DSL, doTry-doCatch-doFinally DSL. We will also learn how to reuse error handling logic and how can we control its boundaries regarding consumer endpoints. Let's begin. As usual, let's start with project overview. We will use a new Camel project, and you should be familiar with this simple configuration already. We have our POM XML with Camel core and login dependency, our main class that creates and runs our Camel context, and one simple route. This route starts from timer component, which just creates empty messages at specified intervals. Then we set body to our message, and then our route throws exception. This simple route simulates an error that might happen in any Camel route. We have our message that we get from some component, and then somewhere along the way our logic throws an exception. So let's start our error handling overview with default settings and just run our route and see what happens. As you can see, here we can see our exception with printed exception trace, and nowhere here we can see our ended route log message. This is because our route was interrupted before it got here, which is expected. This is similar to how exceptions work in Java or many other languages. So, by default, Camel has this default error handler, which just prints exception stack trace and this message history. The message history is a list of steps that were taken before the exception occurred. In our case, this is just a from statement. The main takeaway here is that by default, we have a default error handler enabled. So let's look at what an error handler is and which error handlers are available apart from the default one. We can assign error handler to our route by just specifying .errorHandler and providing error handler reference here. So let's just take a default error handler, run our route, and we will see that nothing changes because, again, this is basically a default configuration. We don't need to write it. It is enabled in any Camel route if we don't say otherwise. Error handler processes our exception or error when we don't have any other means to handle it. We will look at this means shortly. But for now, let's see what we can configure with our default error handler. It has its own DSL, and we can use it to, for example, configure our error handling behavior. The main properties that we can set here are redelivery retries amount and redelivery delay. This means that our message will be retried 3 times with a delay of 500 milliseconds. In our case, this is pointless because we know that we are getting the exception. But in many other cases, this might make sense because, for example, if we're getting an HTTP timeout, then trying again might be a valid option. It is also worth noting that when we retry our message, it is retried from the point of failure. So when we retry our message 3 times in this example, we're actually retrying this process step 3 times, but we don't set body 3 times. This might be important in the case we do some processing before we encounter an error. In this case, the steps before the one that caused an exception will not be retried. By the way, these options are available on any Camel error handler, because any error handler has default error handler definition as its parent. So let's take a look at the other error handlers available in Camel. Second most used one is DeadLetterChannelErrorHandler. It sends all messages with exhausted delivery attempts to this endpoint URI. Let's try to send our messages to file src main resources files error, and let's specify file name example error.txt, and let's try it out. So, as you can see, our message was retried several times. Here redelivery delay is calculated, here it is calculated again, and here, as we have maximum redeliveries equals 3. And finally, after we exhausted all our redeliveries attempts, we stored our message that caused the exception in this deadletter file. The common usage for this deadletter channel is specifying deadletter queue when working with queue managers like Artemis or any other MQ. So use DeadLetterChannelErrorHandler when you want to store your problematic messages somewhere. And the last error handler we'll take a look at today is NoErrorHandler. As you might have guessed from its name, it is used when we want to disable default error handling for some reason. For example, we don't want to produce the logs, or we want to do it for testing purposes. Apart from that, it has little use, and that's why we will not talk about it much more. So, to sum things up with error handlers, we have a default error handler that is enabled by, well, default, and we even don't need to specify it. We have DeadLetterChannelErrorHandler that sends messages which exhausted their redelivery attempts to this endpoint URI, and we have NoErrorHandler if we want to disable default error handling altogether. Actually, we also have several transaction error handlers, but we will look at them in later videos, when we will be talking about transactions. And the last thing to remember about error handlers is that they are executed only when the exception thrown during the flow of a route is not handled in a route itself, in a ways at which we will look at next. Similarly to Java and many other languages, Camel routes have try and catch mechanisms. We can specify them with doTry, doCatch, and doFinally DSL Elements. Similarly to our choice when DSL Elements, we need to specify a branch of execution after each statement. For example, here in catch block, we will be just logging our message. Let's log something like catch exception. And here in simple language, we can actually specify exception to get its string representation. And in doFinally, let's do the same, just log in our finally branch. And same as with choice when construction, we need to close this whole thing with end DSL element. Now let's run our route and ensure that it works the same as you would expect from regular Java try-catch-finally block. Here in our logs, we can see that our exception is catched. By the way, here is our simple language expression returned to string representation of our runtime exception. And here is our finally block that was executed. So, as you can see, it's very simple construction and very similar to regular Java exception handling mechanism. What we can also do is specify onWhen in our doCatch clause. And here we can set conditions or predicates for our exception to be caught. For example, we can set condition that our exception should only be caught when it contains string example. So let's try it. And here we can see that our catch clause is working, but if we replace our example exception string with something like test exception and run again, we will see that only our finally block is executed and exception is not caught. So this is how doTry-doCatch-doFinally DSL elements work. Pretty simple. But what if we want to specify our error handling logic for the whole route instead of for just doTry block? This is when we need to use onException DSL element. Let's copy this route, call new one onException example route, and here let's just delete our doTry construction. So to handle exceptions on a whole route, we're specifying our onException clause like that. And of course below we should specify our branch of execution in the case that we actually catch some exception. Let's just log exception and log the exception object, and similarly to the previous try-catch-finally construction, we should close it with end element. This configuration is very similar to wrapping all our route with doTry-doCatch block. Similarly, we can specify onWhen here and pass a predicate, but let's not do that for now. What is different from doCatch block is that we can specify redelivery parameters like maximum redeliveries or redelivery delay in the same block. Let's see how it works and run our route. And for that, we need to just add it to camel context instead of our previous route. So let's see the logs. As we can see here, we have our stack traces, and here is our onException execution branch, which is logging this exception. All works as expected. What we also can do in onException block is to mark an exception as handled. This means that Camel will count the error as processed normally and will not forward it to error handlers. So in our case, if we run this, we should not see any message history logs as they are done by default error handlers. And as expected, our exception is marked as handled, and this is why we don't see any stack traces. Camel does not count it as an error anymore, and an exception object is deleted from our message. But the message processing does not continue. It stops at the step that caused an exception. And in rare case we want to continue processing our message as normal after we dealt with our exception, we can use continued DSL element. This means that after these exception processing steps, message routing will continue. So in our case, we should see this log ended route message. And as you can see, here it is, as expected. This is because after continued, we went further to our next processing step. So this is all DSL elements we have to handle errors in Camel: ErrorHandler, onException, and doTry-doCatch-doFinally construction. Before we continue, let's talk about their scopes. So, what we usually want to do is to have similar error handling logic for all or almost all our routes to not repeat ourselves and keep our routes clear. But this kind of onException clause scoped to the route in which it is declared only. So what we can actually do is we can declare onException and ErrorHandler clauses in our configure method itself. This way they will be applicable for any route declared in this configure method. For example, this configuration will work for all routes that we declare here, and in our configure method we can have as many routes as we want. This configuration is good when we have only one route builder class, but usually we have many, and even in our simple example we have two classes that extend route builder, each of them having its own camel route. If we want to specify error handling logic in one place for both of these route builder classes, what we can do is we can create a new base class. Let's call it error handling example. Then we should make this class abstract so that it's not instantiated, and extend route builder in the same way as we did with our routes. Now let's just copy this signature, paste it, and here we will put our error handling logic. Now, to make this logic work in our routes, we extend from our error handling example instead of route builder, and in our configure method we can just call super.configure, and the same we can do in our first example class. This is how it was done in earlier versions of Camel, and if you work with legacy code bases, we will probably encounter such error handling logic separation. But in modern versions of Camel, we have a way to decouple error handling logic from the class hierarchy. This is done with route configurations. Let's copy our error handling logic and call it error handling configuration example. Here we don't need to make it abstract, as we will need to instantiate it, and instead of extending route builder, we need to extend route configuration builder, which, similar to route builder, has only one method, configuration. In this configuration method, we should use route configuration DSL element, specify our route configuration ID, let it be example error handling, and now we can use regular error handling DSL to configure our error handling logic. So here this route configuration provides this onException clause, and when we apply our route configuration to any of these camel routes, it will be the same as specifying this onException clause here in routes themselves. To apply our route configuration, first we need to return to extending route builder, as we will have our configuration through this route configuration ID element, and here in this ID we should specify our ID string. So let's do the same for the second route and for our first one. To make it work, of course, we should add it to our camel context. By the way, be aware that route configuration should be added to the camel context before the route that uses this configuration is added. So we need to add our configuration first, and then we can add all our routes that use it. Also note that if you don't want to specify configuration ID for each of your routes, you can have a nameless configuration, just delete this ID, and in the case you have a configuration that has no ID added to your context, then it will be applied to each route that does not have this route configuration ID. So it will be used as fallback configuration. For example, here, imagine we have two route configurations, one with this ID and the second without ID. For this route, the configuration without ID will be applied, and for this route, named configuration will be applied. So this is how you can make a default route configuration. With route configuration, we've covered two most common ways in which error handling logic is decoupled from routes themselves. The older way that is not used now is to inherit from base class and call super.configure method, and a more modern approach is to make route configuration in which we specify all our error handling logic and then reference this route configuration in our routes. And the last thing we'll discuss today is error handling boundaries. You see, by default, Camel applies our error handling logic only after exchange has been created. So, if something goes wrong in a consumer before it is able to create an exchange, for example, a file might be deleted before it is fully read, or some other reading error can happen, then the exception will not be handled by Camel and will be thrown to outer thread instead. Usually, we do not face this problem because with right consumer configuration, the situations in which it gives us errors are rare, but in the case we still need to handle consumer errors before it creates the exchange, we can specify this bridge error handler equals true and point URI option. If this option is specified, then all exceptions occurring in our consumer will be handled by the Camel error handling logic we've set up. This bridge error handler option is available for most of Camel components, and you can check in the documentation if it's there for the particular component you're using. And with that, here's the end of our video on error handling in Apache Camel. Thanks for joining. Be sure to like, subscribe, and hit that bell icon. And if you have any comments or questions, leave them down below. I will answer to all of those. See you in the next video. Until then, happy coding!